Welcome back. We're going to continue solving these systems of equations. Basically, we're going to use the same addition and subtraction technique from the last few sections, but we're going to add one more element to it. I think it's going to be much easier to see what I'm talking about when we put a concrete example down. So what if you have the system of equations 2x plus y is equal to 8, and you had another equation that was 3x minus 2y is equal to 5. Now first, I want to say that this is a system of equations with two variables, x and y, and we also have two equations, so we should be able to solve it. And I want to also reiterate to you over and over again that you could solve this lots of different ways. There's no right way to solve it. So you could graph this and graph this, just like we've done in the past. You could see their intersection point and write it down, and that would be the solution. Or you could do substitution. You could solve this for y, for instance, stick it in here, find x, stick it back in here, and you would get x and y from substitution. All right, that's perfectly valid. Now, we would like to do this by addition or subtraction, but the problem is if we add this and this, we'll get 5x, and if we add this and this, we're going to get negative y, so we're not canceling anything. So at first it appears that you can't do anything really with this, with addition and subtraction. But then I'm going to remind you that an equation is something that you can basically do whatever you want to both sides of the equal sign, as long as you're doing it to the left and to the right hand side. Like if you add something to the left and to the right, that's fine. If you multiply something to the left and also to the right, that's fine. And in that case, you haven't really changed the equation, you just changed the way it looked. So let's just say that I take this system of equations and I choose, and you'll see why in a second, I'm going to multiply this entire first equation by the number 2. That means I have to multiply the left by 2 and the right by 2. And I'm not going to do anything to this equation. So let's do it again and see what happens. So the original equation is 2x plus y is equal to 8, and the second equation is 3x minus 2y is equal to 5. Now what I'm going to do is I'm going to multiply the left side of this equation by 2, and I'm going to multiply the right side of this equation by 2. So I can do that. That's perfectly fine. Now what happens when you do that, when you do the math here? Well, the 2 is going to multiply times 2x and also times y. So what you're going to get is 4x plus 2y. And on the right-hand side of the equal sign, 8 times 2 is going to be 16. And I'm just going to copy down the second equation. 3x minus 2y is equal to 5. So let me ask you now, if I gave you this originally, how would you solve it? Well, you immediately see that you have the 2y and the negative 2y, so you can do this with addition, right? So we're going to finish solving the problem in a second, but basically you've transformed the original set of equations into a new set of equations